Okay, today's question is non-zero eigenvalue. So it's actually a hard question, and I got it right by accident. And then afterwards, I was able to work backwards and understand the answer, but I got lucky for this one. So we have a xn, which is equal to 1 to all the way to n transpose of n. And let's define an to be xn of xn transpose. For any fixed n, there's a single non-zero eigenvalue. Call this eigenvalue lambda n. Find the value of k such that lambda n divided by n to the kth power converges to a finite non-zero value. Okay, so what I did was I thought that it was supposed to be a let's say x to the xt structure. So then I used dot product and then I solved. But essentially, that doesn't necessarily work out. I would definitely need to first get the matrix, then work out the rank, then go to the trace, then solve. But I essentially get the same thing because it worked out. But I think it's better that I actually do the proper way. So the first thing that we noticed inside the thing was that the rows of AN are definitely linearly dependent because our AN, it says it only has one eigenvalue that's non-zero. So then our rank is 1 and our n minus 1 eigenvalues are equal to 0. So next we know there is the trace of the matrix. That trace is basically the value of the diagonal elements summed together. And trace is equal also to the sum of the eigenvalues weighted by algebraic multiplicity by this. So then what we can use is that we can find that we know lambda 1 to lambda n minus 1 is equal to 0, lambda n is our trace. And then we also know that inside here when we calculate xn to the xn t, it looks something like this. So then we have on the diagonals 1 squared, 2 squared, all the way to n squared. Let me check. Xm was originally set to be this one, 1, 2. So then this is Xn is a column vector. So then that's why we have a square matrix of size n. So then we get the trace is equal to 1 squared, 2 squared, all the way to n squared. And then we can simply solve 1 squared plus 2 squared all the way to n squared is n times n plus 1 times 2n plus 1 divided by 6. So then we see that the power of n is to the third power. So then if we want this lambda n divided by n to the kth power to converge to a finite non-zero value, then we would need the k to be a 3 as well. For this question, I mistakenly did it the way that I messed up the column and row vector. So I thought it was a row vector. So then I screwed up the order and I thought I used the dot product. But fortunately, because I just used dot product, I still got the values on the diagonal. So my trace was the same. So then I was able to arrive at the same conclusion. But obviously, you do have to realize that it's an n times n matrix rather than a 1 by 1 scalar. Okay, that's it for today. This question was quite interesting.